From the company Longer I received a 3D printer type LK5 Pro in order to record a video with this device. I agreed to this offer because 2 spools of ABS filament had been lying in a corner of my workshop for several years, waiting to be processed. The reason for the disappearance in that corner was that ABS tends to twist and get loose from the build plate during printing, and PLA or PET are much easier to process. Ideas to fight this kind of distortion during printing have evolved in my brain over the years, and it is now time to prove if they are good ones. But first a few words about the Longer LK5 Pro, which I choose for this project for certain reasons. Inside a metal box in the base of the device is the mainboard with removable stepper motor drivers which can be quickly replaced in the event of damage. The wiring looks tidy, and the source code of the firmware running on the ATmega 2560 is published by Longer. That's how it should be, because closed source devices no longer will enter my workshop. With the open source firmware there are no barriers for my ideas. I have full control over the stepper motors, fans and heating elements of the 3D printer. The LK5 Pro ships largely pre-assembled. Only the upper frame has to be screwed on the base, the touchscreen has to be mounted, a few small parts have to be screwed on, and finally a couple of cables with reverse polarity protected plugs have to be connected. As always, there are high resolution pictures of the printer available on my website. The printhead can be moved to the corner points of the print bed via the touchscreen, and this can then be leveled using the easily accessible adjusting screws. Thanks to the large hand wheels you can quickly readjust the build plate even during operation. Once this is done, a first print job can be started. Unnecessary VLAN frippery is not available. Print data is received in the good old school way via USB interface or microSD card on which a file named boat is stored out of the box. And yes, of course the Longer LK5 Pro can print Banshees. I use blue PLA that I had in stock for this print. The 10m black PLA that comes with the printer would be enough for a Banshee, but black doesn't give a good contrast for video recordings. The quality of the print is good, I can't find anything to complain about, but I am for sure no expert in Banshee printing. There are high resolution photos of the finished print on my website, so that you can get your own impression of the print quality. Let's wipe the mini steamboat away and start to print something useful. The blue PLA has been replaced by grey ABS, and the SD card contains the print data for a gear rack that is almost 40cm long and 2cm wide. The print data in G-code format for the first attempt shown here was generated as usual. I created an STL model with OpenSCAD and processed it for printing with Slicer. The print bed of the Longer LK5 Pro is suitable for objects with a base area of up to 30x30cm. The gear rack only fits on the coated glass plate at a 45° angle and extends from the rear left to almost the very front right. I wanted to use the full diagonal. Since ABS shrinks noticeably when it cools down and thus tends to peel off, I coated the print bed with a glue stick. It's no magic stick, I bought this one for very little money in a store around my corner, a cheap glue for paper. The temperature of the hot end is set to 240°C and the first layer of the gear rack is printed with a speed of 10mm per second. The following layers are printed at 30mm per second. The print bed is heated to 100 degrees Celsius, which is the maximum temperature of the LK5 Pro. As already told, ABS tends to get loose from the print bed because of the strong shrinkage when it cools down. Which indeed happened in course of the print job. Anyone who has ever printed with this material knows about that problem. Standard procedures for fighting this effect, named warping, are attaching mouse ears to the CAD model or printing in a heated enclosure. Especially for bad adhesion, miracle cures are sometimes advertised. Not with me. My intention was to use an even more exotic material, brain. First, the well-known strand of plastics is printed around the base of the gear rack, and this extends from the very back on the left to the very front right, and back to the rear left corner. There, a filled square is printed, on which several layers of triangles are stacked on top of each other, which results in a tetrahedron. Starting from this anchor point, the base plate of the gear rack is now printed. The printing is not done in horizontal layers. Instead, new strands of ABS are constantly being deposited on the two front surfaces of the tetrahedron. While doing so, the print head moves up and down along the Z-axis. When the tip of the tetrahedron is reached, the process starts over at the lower edge. The base plate thus grows from the rear left to the front right. For this first print, the base plate is 2.15mm high and consists of 10 layers. The bottom strand is printed with a layer thickness of 0.35mm and a speed of 10mm per second. The following layers are each 0.2mm high and are printed at 30mm per second. The width of the individual strands is set to 0.6mm. The width to height ratio defines the angle of the original tetrahedron and thus the angle of the tip of the growing rack in relation to the surface of the print bed. This must be flatter than the angle of the print head nozzle, otherwise it would touch higher layers. Care must also be taken that the print head does not touch the top layer of the base plate while the bottom line is printed. With the LK5 Pro there's always enough air between the print head and the upper edge of the base plate. The advantage of printing from back left to front right is that the part cooling fan, that is on the right, can't touch the print. As told before, the Z-axis moves up and down during the printing process. With the LK5 Pro, this axis is driven by just one stepper motor and one spindle, located on the right, here. The left side does not have its own drive. The mechanism works very well thanks to the backlash-free guidance via V-slots in the extruded aluminum and the plastic rollers with ball bearings. The base plate of the rack continues to grow to the front right at a little more than 3mm per minute. As in the first experiment, the bed heating is set to 100 degrees Celsius. The LK5 Pro was operated more or less constantly with this print bed temperature during my experimentations, and the electronics worked without any problems all weeks long. The reason why I don't print the base plate straight from bottom to top but with a 90-degree angle is the higher sturdiness of the finished part. 3D printed parts are stronger when forces are directed along the printed fibers, and they tend to crack perpendicular to the print direction. After a bit more than 2 hours, the front right corner is reached. Here another mouse ear is printed, just like at the beginning it consists of a triangle growing out of the bottom layer. Now the construction of the front face of the baseplate starts. The triangular tip is filled first at the left, and then on the right side. The last step is to fill the now straightened front angle. I generated the G-code data for the gear rack with the help of a Python script. This software is available as download on my website so that you can reproduce my experiments and change parameters while doing so. What is still missing are the teeth on top of the baseplate. These are printed as usual in horizontal layers, as the angle of the teeth is too pointy to be printed using the same principle as the baseplate. The teeth only extend to the center line of the baseplate. The ambition temperature in my video studio is around 20 degrees Celsius. The gear rack is finished after 2 hours and 45 minutes, it did not come off the baseplate anywhere during printing. Not until the print bed was cooled down, the gear rack largely detached from the glass plate. After removing the print completely, it can be seen that a bulge with a peak in the middle of the bar has formed. Even with this printing method, tensions build up in the part, these are only directed more or less away from the horizontal layers. Basic mission accomplished, let's start freestyle. The second rack is printed with a significantly higher base plate. Instead of the 2.5mm in the first run, it is now 3.35mm. With the LK5 Pro, the lower edge of the print head still has a sufficient gap to the upper edge of the base plate. If you look closely, you will see that the edge at the beginning of the gear rack has peeled off slightly. Nevertheless, the base plate is printed without any problems. And even when the row of teeth is printed, the workpiece still sticks well on the print bed. The job is completed after 3 hours and 10 minutes. There are high resolution photos of the results on my website, as well as further comments on the printing process. The next test is printed on the smooth back of the glass plate, which in principle means poorer bed adhesion. But of course again I applied a coating with my cheap glue stick. A 100x50mm plate with a height of 2.15mm is printed. A pentahedron is formed as an anchor point. This consists of rectangles stacked on top of each other. A total of 10 of these result in the required height. The main body now grows on all 4 sides. Thus, the part cooling fan must be taken into account as the lowest point of the print head. If you want to print even higher, this must be removed. The heat bed is again adjusted to 100 degrees Celsius. In the video studio, the ambition temperature has now climbed to a bit more than 21 degrees Celsius. When the final dimensions of the base area are reached, the edges are filled. The job is finished after about 1 hour. Even after the print bed has completely cooled down, the print still sticks fully to the glass plate. If the same part is printed conventionally, meaning in horizontal layers, Once again the print separates from the build plate at the end of the job. Congenial with the video theme, so-called moire patterns form on the glass plate in this shot, with the help of which warping of materials could be visualized. So, did I demonstrate the holy grail of warp-free 3D printing? Unfortunately not. The procedure is definitely helpful for special print jobs, but the use cases are limited. You can try out for yourself how big you can print and whether what I have figured out really works. As told before, the Python scripts that I use to generate the G-code commands are available for download on my website. There you will also find the OpenSCAD, STL and G-code files that I used in this video. You can see that the base starts peeling off when printing 2mm thick walls on top of the plate in order to get a box made of ABS. So there is more to explore, reflect and more experimentation to be done. If you would like to support me financially, you are welcome to click the donate button on my pages. Many thanks to all the great people who have already made use of it. Also many thanks to Longer for the LK5 Pro that I used to carry out my experiments. Further experiments in 3D printing, which I will share with you following the spirit of open source, are already in my brain. Stay tuned to see the results. Thanks for watching and I'll be back.